Hello student. In previous video we have discussed about conservative forces, electric potential and its SI unit volt. So what is electric potential? Electric potential at a point is the work done in bringing a unit positive charge from infinity to that point against the electric field. So today we will discuss electric potential due to point charge. Point charge means it is a single charge. Due to that single or point charge, we have to find out electric potential around it. So how to calculate that electric potential and which formula we have to use, we'll see today. And we'll derive a formula for electric potential due to point charge. Now to derive that formula, we have to consider a point charge first, right? We have to consider a point charge, call that point charge as a Q and at place O. Consider a point charge Q, place that point O. Now due to this charge, around electric field will be there, right? Around this charge, electric field will be there. In that electric field, we have to calculate electric potential at any point. So to calculate electric potential, consider a point P, and point P is at a distance r from the your point charge. Point P is at a distance r from the O or Q. Now to calculate electric potential at this point P, we need to consider a unit positive charge at another point, right? Call that another point as P dash. Here it is, right? He is at this point P dash. We have to consider unit positive charge. Unit positive charge is nothing but a charge having plus 1 coulomb, right? A charge having charge of plus 1 coulomb. Now suppose we keep this plus 1 coulomb charge at point P dash. Now according to Coulomb's law, the electrostatic force will generate in between this point charge and this plus 1 coulomb charge, right? Which electrostatic force will be generated here? Repulsion force, right? And this force is given by Coulomb's law. You know Coulomb's law. Electrostatic force is directly proportional to the magnitude of their charges and inversely proportional to the square of distance between them. Now distance between your unit positive charge, your point charge and unit positive charge is r dash. The distance between them is r dash, right? Now apply Coulomb's law here, right? According to Coulomb's law, electrostatic force F is equal to 1 divided by 4 pi epsilon naught, right? And their magnitude is q into 1 and square of the distance divided by r dash square. It is r dash, right? R dash square. And it is Coulomb's law of electrostatic force between point charge and unit positive charge. Now suppose consider this unit positive charge is moved through a small distance, that is delta r dash. See here, delta r dash distance it has moved. Then what will happen? A displacement is there, and to travel that distance, an external force will be there, right? Force and displacement is there. Then work done must be there, right? Work is force into displacement, right? So that work done is given by delta W is equal to minus F into delta R dash, right? Why minus F here? Can anybody guess, right? Why minus F is because of it is work done is against the electric field, right? Electric field will be in this direction. You are moving your point charge in this direction, opposite direction. That's why minus sign will come here. So this is work done. It is small work done for small distance, only this much distance. How much is the distance? Delta r dash, right? For delta r dash, delta W is the work done. So to calculate potential at this point, you have to consider total work done from infinity to up to here, right? To calculate that work done, what you have to do? We have to add all these small delta W from infinity to point P, right? From infinity to point P. Point P is at a distance r, right? So after integrating this equation from infinity to r, we'll get total work done at this point P, right? So to calculate total work done in moving unit positive charge from infinity to r, what you have to do? We have to integrate all small works, right? So integrate them. Here it is. W is equal to integration of infinity to r delta W. So next step, what will happen? Work done is equal to integration of infinity to r. You know the value of delta w, right? You know the value of delta w. Here it is. Substitute here, then you will get integration of infinity to r minus f into delta r dash, right? Everybody understood how this equation comes, right? So next will be, you have to substitute something for your this f. You know the value of f also, right? What is that value? Right, here it is according to Coulomb's law, f is equal to this much is there, right? So substitute that value in next step here. So work done is equal to integration of infinity to r minus, because f is minus, here it is positive, here you have considered that negative because of it is doing work is doing against the electric field. That's why here you have to take as a minus. So work done is equal to integration of infinity to r minus 1 divided by 4 pi epsilon naught and q divided by r dash square into delta r dash. Up to here it is f value and it is as is, delta r dash is as it is, right? So next step, to do integration you have to consider same variables, right? R dash and delta r dash, right? So keep r dash and delta r dash inside the integration here, see, and rest all take outside the integration. So next step will be w is equal to take all outside the integration except r variables, right? So work done is equal to minus q divided by 4 pi epsilon naught integration of infinity to r into bracket r dash raised to minus 2 delta r dash. How this r dash raised to minus 2 comes, right? R dash raised to minus 2, how it comes, that is a point, right? So for that, see this equation again here. Here r dash raised to square in the denominator, right? If you took up means if this denominator comes in the numerator, its power must be negative. Here it is r dash raised to square and here it is r dash raised to minus 2. Clear? So work done will be how much? Minus q divided by 4 pi epsilon naught integration of infinity to r dash minus 2 delta r dash. So next w is equal to, next what you have to do, you have to integrate now. Previous step was what? Integration of infinity to r dash raised to minus 2 delta r dash, right? So integrate that. To integrate that, you know basic formula, integration of x square dx, right? Imagine integration of x square dx is equal to x raised to 3 divided by 3. How it comes? X raised to 2 plus 1, right? X square means x raised to 2. Integration of x raised to 2 is x raised to 2 plus 1 divided by 2 plus 1 it is, right? In the same way, what you have to do here, r prime raised to minus 2 plus 1, right? Divided by minus 2 plus 1 into bracket infinity to r. It is integration of r prime raised to minus 2. This circle marked circle is indicates that it is the integration of r prime raised to minus 2. You know the basic formula how to integrate. Integration of x square dx you know already, right? So work done is equal to, what will happen here? Minus q divided by 4 pi epsilon naught bracket r dash raised to minus 2 plus 1 divided by minus 2 plus 1, close the bracket it is, and mention the limit here infinity to r, right? And next what will happen? Simplify this bracket, right? See here r dash raised to minus 2 plus 1 means what? Minus 2 plus 1 is minus 1, here it comes minus 1, right? Divided by minus 2 plus 1 is again minus 1. So next step will be work done is equal to minus q divided by 4 pi epsilon naught into bracket r dash raised to minus 1 divided by minus 1, close the bracket, limit infinity to r, right? Now next step, take this r dash raised to minus 1 in the denominator, this r dash raised to minus 1 in the denominator. What will happen now? Tell me. If previous only you have seen, right? R dash square was in the denominator. If you take upside, what will happen? Its sign will change. If it is plus, it becomes negative. Now here apply the same rule. It is in the numerator, right? If you take this in the denominator, r dash raised to minus 1, if you take r dash raised to minus 1 in the denominator, its sign will obviously change. Here it is minus, it will become plus here, right? So work done is equal to minus q divided by 4 pi epsilon naught into bracket minus 1 divided by r dash raised to 1. It is r dash raised to 1, nothing will be there, in the sense raised to 1 will be there. So minus 1 divided by r dash, close the bracket, mention the limit infinity to r. So what is your next step to do here? You have to imply this limit in the place of r dash. In the place of r dash, keep r once and plus keep infinity once. You will get the integration value, right? So see here. So work done is equal to minus q divided by 4 pi epsilon naught into bracket minus. So first substitute the r, that is 1 divided by r dash. In place of r dash, first substitute the r. So it becomes 1 divided by r plus, in place of r dash substitute the infinity. So it becomes 1 divided by infinity. So work done will be minus q divided by 4 pi epsilon naught into bracket minus 1 divided by r plus 1 divided by infinity. Now what is the value of 1 divided by infinity? Anything divided by infinity is the 0. It is the basic thing. Anything divided by infinity is the 0. So substitute the value of 1 divided by infinity in next step. So what it becomes? Work done is equal to minus q divided by 4 pi epsilon naught, right? Q divided by 4 pi epsilon naught into bracket minus 1 divided by r plus 0, right? So next step, minus 1 divided by r and minus q divided by 4 pi epsilon naught. Minus minus, what it becomes? Plus. So make the correction in this equation, it should be plus here. It is not minus. It should be plus here, right? So next step, what will happen? This minus and this minus becomes plus. So how much work done you will get total? W is equal to q divided by 4 pi epsilon naught r. W is equal to q divided by 4 pi epsilon naught r. Now this is the total work done. This much is the total work done in moving a point charge from infinity to your point P. And according to definition, this work done should be stored as potential, electric potential in the your point charge. So at point P, this work done should be electric potential. So and thus this work done is electric potential at point P. So V is the what? V represent electric potential. So V is equal to Q divided by 4 pi epsilon naught R is the total potential at a point P due to point charge Q. Clear? It is the total potential at point P due to a point charge. Clear? It is the derivation of electric potential due to a point charge. So next things we'll see in next video. Thank you.